All right. We got through quadratic formula, the quadratic formula problem yesterday or Friday, yes? So we did one of these Friday?
No.
Or 26 or 27?
No, we got it.
Okay. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this here is the quadratic formula. So for solving equations by the quadratic formula, the first thing we need to do with either equation, any equation, is get that equation equal to 0. Do we want to look at 26 or 27?
26. Bro, no, we were on 28 squared.
No, we weren't.
Me and Colton both thought so. Yeah. We're right. We're right. You're wrong.
All right, guys, focus in, focus in. So we'll look at 27. The first thing we need to do is get this equation equal to 0. Now, one way we can do that is by adding 4x squared to both sides. So we have 4x squared minus 7x plus 6 is equal to 0. Because 4x squared and 7x are not like terms, so we can't combine them. And the reason we get it equal to 0 is because we need to know the values of a, b, and c. A is going to be the number in front of x squared, which is 4. B is the number in front of x, which is negative 7. And c is our number without a variable, which would be 6. A cannot be 0, but B and C, if we don't have an x term or a constant term, it can be 0. But for the most part, on the test, we will have values for A, B, and C. We'll have a number for all of them. A is the only number that cannot be 0. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the first thing we can do is just replace a, b, and c with their values. So we have negative b, which is going to be negative 7. B squared, so we'd have negative 7 squared minus 4 times a, which is 4, times c, which is 6, all over 2 times a, so 2 times 4. We replaced a with its value of 4. We replaced b with its value of negative 7, and c with the value of 6. So all we've done so far is just replace a, b, and c with their corresponding values. Questions on this so far? After we get it plugged in, we need to start simplifying down. Negative 7 is just going to be positive 7. On bottom, 2 times 4 is 8. Now at this point here, we can plug everything inside the radical. I would not plug the radical, but I would plug everything that's inside the radical into the calculator. So we have negative 7, so parentheses, negative 7, close parentheses, squared, minus 4 times 6, which tells us it's negative 47. So we have negative 47 inside the radical. So we have x is equal to 7 plus or minus the square root of negative 47 all over 8. Now for this here, we do need to see if the square root of negative 47 does reduce, and it will reduce because that negative is going to have to come out as I. Whenever we have a negative inside the radical, it's got to come out as I. So even if the square root of 47 doesn't reduce, we've still got to take that negative out as I. Now the graphing calculator will take the square root of negative 47, but most likely it's going to give us a decimal if it doesn't simplify nicely. The 30xs will not take the square root of negative 47, but at this point we're really just taking the square root of 47. Because the negative came out as I, we're trying to see if the square root of 47 reduces. Lo and behold, it does not. So That tells us that the square root of negative 47 is I square roots of 47. We get this here. On top are 7 and 8, or 7 and I do not have like terms, let alone 7I and 8. So this is as simplified as it gets. If it can reduce, we do want to reduce it, but I would tell you guys the biggest thing I'd emphasize is as you're reducing step by step, write it out. Write it out part by part. That way, if for some reason you decided to try to simplify this, it looked like it could, you simplified it and it actually doesn't, but have the step above it, I will take it. Even if you simplified it where it didn't need to be or incorrectly, as long as you have this here listed, I'll take it. Questions on quadratic formula? We feel good about the quadratic formula. Yes? Find the value of the discriminant. Find the type of solutions and solve. Now, if the discriminant b squared minus 4ac is greater than 0, it tells us we have two real solutions. If it is equal to 0, we have one real solution. And if it's less than 0, we have two complex solutions. If the value b squared minus 4ac is greater than 0, we have two real solutions. If b squared minus 4ac is equal to 0, we have one real solution. And if b squared minus 4ac is less than 0, we have two complex solutions. We have two imaginary solutions. (28) or 29, which one do we want to look at first? Or which one of these two do we want to look at? 28, 29, they're both the same. First thing we got to do is get this equation equal to 0. Now, it doesn't matter which way we move or what we move. I'm going to subtract 4x squared from both sides. Because on the left-hand side, 4x squared minus 4x squared would be 0. So we have negative 4x squared plus 5x minus 10. The alternative is that we subtract 5x from both sides and then add 10 to both sides. But I would rather move one term, move the 4x squared term from the left to the right, than to move everything from the right to the left. I'd rather move one thing instead of two. Now at this point in here, it tells us the value of A is negative 4, B is 5, and C is negative 10. So what we want to find is the value of b squared minus 4ac. And all we got to do is plug our values in. So b is 5, giving us 5 squared, minus 4, times a, which is negative 4, times c, which is negative 10. So all we've done is plugged in the values of a, b, c. Questions on this here so far? So we're calculating 5 squared minus 4 times negative 10. 5 squared minus 4 times negative 10 is negative 135. So that there is the first part of your answer. We have to find the value of b squared minus 4ac. Now, because it is less than 0, it tells us that we have two complex solutions. We need to find the value of the discriminant, are, in this case, negative 135. Since it is less than 0, it tells us we have two complex solutions. Because if b squared minus 4ac is less than 0, we have two complex solutions. Questions on this here? Now, the answer key for the review also has the solutions, because the review sheet I did ask you to go on and solve it. On the test, you're not going to be asked to solve it. All you're going to be asked to give is these two things. Value of b squared minus 4ac and the number and type of solutions. So for this here, if it was on the test, we would give negative 135, two complex solutions, and that's it. So we don't need anything else. The answers on the review do give the solutions. So if you do want some more practice getting or simplifying radicals or simplifying using the quadratic equation, you'll want to do it. But this part of the test, this is all it's looking for. Questions on this here? Let's look at 30. Now again, just like our last one, we do need to get this equation equal to 0. We need everything on the same side. I also reorganized our term so that we do have it in standard form, our x squared x constant term. It's going to help us be able to find the values of a, b, c. A is the number in front of x squared, b is the number in front of x, and c is our number without a variable. A is always in front of x squared, b is always in front of x, and c is the number without x. At this point here, we can just find our b squared minus 4ac. B is negative 24, so we have negative 24 squared, minus 4 times negative 3 times negative 48. And at this point here, I would grab the calculator, plug it in exactly as it is, let it do the work for us. Negative 24 squared minus 4 times negative 3 times negative 48, which is 0. And since the value of the discriminant is 0, we have one real solution. If we have a positive number, we have a number greater than 0, it would be two real solutions. Questions on any of this here? Are you ready for the next part? Perfect square trinomials. Perfect square trinomials. We need to find the value of c that will make this a perfect square trinomial and factor it. So we look at 31. X squared minus 24x plus c. So we need to find c first. C is equal to b over 2 squared on all of these here. The number in front of x squared will be 1. So we don't have to worry about making it 1 because it'll already be 1. By looking at this problem here, what's the value of b? Negative 24. Will negative 24 over reduce simplify nicely? Really, is negative 24 is 24 divisible by 2? Well, yes. Negative 24 over 2 will reduce to negative 12. And negative 12 squared, negative 12 times negative 12 is 144. So there's half our answer, 144. That's the value of c. We do need it listed. And specifically on the test, if you want to rewrite it back out as x squared minus 24x plus 144, you can. You do not have to. I'm just looking for that value of c. Now, the second half is to factor it. So we're going to have our single set of parentheses squared, and we will have x. Now, the main reason I write out finding c is because the number in sign that goes inside the parentheses with x is our number in sign inside the parentheses before we squared it to find the value of c, which in our case is negative 12, telling us it factors to x minus 12 squared. And that's it. If you're not sure that the value of b over 2, that b over 2 simplifies, write it out, throw in the calculator exactly as you see it. Don't put the parentheses, don't put the square, just see if it reduces. If it does, rewrite it in the reduced form. If it doesn't, we just square it. Because if we look at 32, what's our value of b? It's positive 29, yes? Does 29 over 2 reduce? No, it's not an even number, so it's not going to divide by 2. If we're not sure, we can go 29 over 2. And the calculator tells us that it's 29 over 2. At this point here, we can just say 29 over 2 squared is 841 over 4, telling us that our value of c is 841 over 4. and the number and sign inside the parentheses before we squared it was 29 halves. So it tells us it factors to x plus 29 halves squared. And that's it. So if they gave us, say, 29 halves as the value of b, well, that means we'd come in and say, well, the top is 29 halves over 2. Okay, it does simplify to 29 fourths. We put that in the parentheses, and then we would square it. Which tells us that it's 841 over 16. Same process. But just if we have fractions and fractions, we do need to simplify. Also, the value of c will always be positive because we're multiplying it by itself. We're squaring it. Square a negative number is going to be positive. Square a positive number, it stays positive. That value of c should always be positive. What's inside the parentheses before we square it can be positive, it can be negative. But our final value of c, the actual value of c, is always positive. Questions on 31 or 32? Are you ready to hit the hardest part of the test? Powers of I.
Oh no.
Anytime we're given I to a power, I to an exponent, we take whatever that exponent is and divide it by 4. If we get a decimal of 0.25, it reduces to I. If we get a decimal of 0.5 or 0.50, it's negative 1. If we get a decimal of 0.75, it's negative I. And if we get a decimal of 0.00, well, if the decimal is 0.00, it actually won't give us a decimal unless we set the calculator to specifically always give a decimal to 2 places. It's just going to divide evenly. We won't have a decimal at all. So really all we got to do is take that number, divide by 4. So the first one, 27. Now we could write it as a fraction, 27 over 4, which is going to tell us it's 27 over 4, which we're going to have to approximate as a decimal. We might as well just divide it. 27 divided by 4 is 6.75. We don't care about the 6. The 0.75 tells us that this reduces to negative I. And that's it. The graphing calculator does do powers of I, because we can do I to the 27th, and it works, I think, pretty fine. Yes? I to the 27th is negative I. Or it helps if I actually put it in the exponent. So it does tell us it's negative I. If we look at I to the 287, it tells us it's 3.7 e to the negative 12 minus I. Well, 287 divided by 4 is 71.75. Yeah, so B would be negative I. Now the 2,874, second I to the 2,874 is negative 1 plus 4e, or 4.26 e11, negative 11I. Really, that whole part is 0. Or I think it's easier just to go 2,874 divided by 4. 7 point, so we get 0.5. 0.5 tells us that it is negative 1. So the graphing calculator can do powers of I, but after we get to a certain power, it starts having a pixel error because it's graphing it to get the approximation of how it would reduce. So we start getting that little bit of an error. Might as well just divide it by 4 and check the decimal. Questions on this here? We ready for the next part? A, B, C, D. We'll look at E in a minute, but A, B, C, D, which one of these do we want to look at first? D. $74 minus 6i minus 27 minus 3i is 47 minus 3i. Make sure I type. I see what I did. It should be, well, might as well clear the whole thing out. Because it's 74 minus 6i minus 27 minus 3i. 47 minus 3i. Yep. So really with our addition and subtraction, all we got to do is type it in. We can type it in exactly as it looks, and we'll get our answer. Even if we looked at E, 189, second decimal for I, minus 361, I squared, plus 71, I squared minus 38, I to the fourth. It'll still do it. It'll tell us it's 252 plus 189i. We can type it in to get that power of 4. We use the caret key, the button above the division button, to do those exponents. Another way to do it is you can hit that x squared button, use the arrow as a cursor back up to it, change it from a 2 to a 4. Questions on addition and subtraction? Because we did do them in class at one point, we did do it by hand to get to our answer. But at this point here, we can also just type it in, and we're good there too. Questions on this here? F, G, H, or I? Well, F through K. Which multiplication do we want to look at? H, 2 plus 3i times 7 minus 4i times 6 minus 2i. And again, with multiplication, we can type it in exactly as it looks. All right, guys, focus in, focus in, focus in. We can type it in exactly as it looks, and it'll tell us that 2 plus 3i times 7 minus 4i times 6 minus 2i is 182 plus 26i. That's it. Question on multiplication. Yep. We already looked at division. Now, dividing two complex numbers on the graphing calculator, especially the 84 plus, we cannot use alpha y equals enter. We can't just use the fraction key. So for us here, when we divide two complex numbers in the calculator, we put parentheses around the top, hit our division key, divided by the bottom. We do the top divided by the bottom. We have to change it from a fraction to division, and we put parentheses around the top, parentheses around the bottom. Because once we write it in this form, we can actually type it in. We can go parentheses 8 minus 4i divided by 3 minus second I. And we hit enter. And it will divide it. Now, it gives it to us as a decimal. What we have to do at that point is math, enter, enter. Once we divide it, we're going to go math, enter, enter. And it's so math, the first option we have is turn it into a fraction. So we hit enter to select it, and we hit enter a second time for it to actually apply. So 14 fifths minus 2 fifths I. So to convert to fraction is math, enter, enter, yes. Now, normally with most of the tests and most things you do in here, I do not care if it's in a fraction or decimal form. These I want as fractions. Because for the most part, y'all are already doing them in the calculator to begin with. And all we got to do is hit 3 keys, math, enter, enter. Might as well convert it. So 14 fifths minus 2 fifths I. Even if the numerator or denominator is a single term, make sure to put parentheses around it. Put parentheses around it because it can change your answer completely. Because if we look at n8 plus 3i divided by 6i, so here it does work. It's not doing anything different as if we put 8 plus 3i divided by 6i. Actually, I take that back. If you notice this here, it gave us a completely different answer because what the calculator did on the first one is it divided the 8 plus 3i by 6 and then multiplied by I. So it saw the 6 and the I as two separate things. It worked left to right, so it did the division first and then multiplied second. It did not treat it as one term. So especially, even if the bottom is just a single term, make sure to put parentheses around it.
What are calculators getting standardized?
If they do, they would be banned from a standardized test.
What are they getting classified?
Questions on addition, subtraction, multiplication? Even if it does have exponents, it's still going to work the same way. Just type it in. Let's look at the last four problems here. Find the complex conjugate and their product. So it's asking for two things. So if we're given a plus bi, its complex conjugate is a minus bi. If we're given a minus bi, its complex conjugate is a plus bi. So 4 minus 3i's complex conjugate would be 4 plus 3i. And that's half our answer. The other half is to multiply the two together. Now again, we could do this by hand. We can multiply out by hand if we want. But we can plug it in the calculator too. It'll do it for us. 4 plus 3i times 4 minus 3i is 25. Questions on Q? What would R be? 18 plus 14i would be 18 minus 14i. Then we'd multiply them together. 18 plus 14i times 18 minus 14i. Which would be 520. Yes. Whenever we multiply complex conjugates together, we should get a number. We should not have I left over. Let's look at one more. Or one more for sure. 8i. What's its complex conjugate? Negative 8i, yes?
Yeah.
Then we would multiply them together, negative 8i times 8i. And if we plug that in, it'll tell us it is 64. Because 8 times negative 8 would be negative 64. I times I would be I squared. I squared is negative 1, so it's just going to change it from negative 64 to positive 64. We good on S through T? Yes? Let's throw one more in. Let's see if y'all remember doing this. What's the complex conjugate of 8? It's just 8. Because there's no I, so really we can say that it's 8 plus 0i. Its complex conjugate would be 8 minus 0i. And if we multiply, it'd just be 8 times 8, which is 64. I don't think one of those comes up on the test, but if it does, we know how to do it. because we're only changing the sign in front of the term with I. There is no term with I, so it just comes back out to 8. Questions on any of this here? That is it.